Right, this is about L3VPN, MPLS L3VPN on JUNOS. We got 3 autonomous systems. The customer sides are already configured. The providers, the core, the middle one, the provider network is partially configured. Let me explain you the steps that we are going to do and then what has been configured. This is the step. First we are going to provide the ISO address, means NSAP address for each router. It need to be unique so that ISIs can use it as an ID. Followed by, we are going to put the IP address on all the interfaces, the physical and the loopback, and then we are going to enable the protocol ISIs itself. We don't need L1, so we are going to kill L1 and keep only L2 with the white metric enabled, so that in future we can use the same topology for RSVP. And we got now next step as the MPLS LDP need to be enabled in the core, because without this we cannot have MPLS layer 3 VPN. And then we have the loopback interface, which is going to be used as the router ID for all routing options like BGP, in our case MPLS. So we need to configure this loopback interface, and then the VRF, the VPN instance VRF, so that the customer routes can be separately handled, controlled, not mixing with the global control plane of the ISP. We need VRF. We call it as routing instance here. So that's the next step. Followed by, we map the customer facing interface to the VRF, and then the CEP connectivity, meaning we are going to have the route to be distributed from the customer to the provider and provider to the customer. In our case it's very easy because we are going to use simple BGP. BGP can easily take the route. VPN is also BGP. Customer is also using eBGP. So there is no need for a manual redistribution. We'll see later. So this is going to be CEP using eBGP relationship. And then we are going to form a layer 3 VPN between PE and PE, between PE1 and PE2, and then followed by the CEP configuration VRF. I think I explained that here itself. So the route exchange, and then customer advertises. This I have already done. Customer is running BGP and advertising a network. We are advertising a loopback interface by using route options. We did this yesterday. I'm going to go show you again one more time. Or we can also configure, we can also advertise all the connected network. That will be more easier for us. Advertising 172.16.01 alone needs that filter option which we saw yesterday. But if you're planning for advertising all the connected network, it's very simple like this. Like this, direct. If you say direct, the filter is not needed. The filter option is not needed. I hope you can recall what we saw in the previous class demo, where we use filter and we say only this particular then accept. Here we are going to say no, anything that is direct, advertise. Fine. So to make our things easier, we have the steps to follow. What is already done is we have already assigned the step 1 on all router except PE2. We'll do PE2 at last. We'll finish the other routers so that as a final recap we can use the PE2 and I can explain you all the steps once, from step 1 to step 10, and then we will do a pasting job. So what is done so far is, on all the routers I have configured this one NSAP address. For router 1 is given, router 2 is given, 5 and 6. 5 is Olive 5, which is provided only router, Olive 6. Step 2 is also over on all the devices except PE2. I have assigned IP address on the Ethernet interfaces, IPv4 address, which is a well-known story for us. We know how to configure IP address. And then ISIS is also enabled, except PE2. All the routers are running ISIS. You can see here, this command is necessary. Set route option, route ID, and give an address. And this is the loopback interface address. This will be used by MPLS, BGP. If you run OSPF, then OSPF. They will take this address as a router ID. And then we say L2 wide metric only, which means I do not want L1 and I want L2 with wide metric. Wide metric is very important for segment routing as well as for MPLS traffic engineering. And then I have enabled ISIS on these interfaces and loopback with the passive, so that there is no need for any advertisement on that interface. So it need to be a member of ISO, because it's ISIS protocol. ISIS is designed by ISO, so those interfaces that's supposed to run ISIS need to be a member of ISO family. Next, this is the step that we need to start. The command to enable MPLS on the interface is this: set protocol MPLS, and then LDP has to be enabled again. It's not like Cisco. In Cisco, when we enable MPLS, LDP gets enabled automatically, but here you have to separately do it. So this is where we are going to start. On the PE1 router, I have these two interfaces, EM1 and EM2, which is correctly matching, so I can easily cut and paste. Set protocol MPLS, set protocol ISIS, set protocol BGP, set protocol OSPF. That's how, any protocol you want to enable, you say set protocol OSPF, BGP, MPLS, LDP. So this is a familiar, well-known command. So I'm going to use just copy and paste option, and I'll do it on PE1. Done. Interface EM2.0, and I'm going to commit. So MPLS is done, meaning along with the LDP, MPLS is done on this router, and I'm going to paste it separately for router 2 so that we can do a recap later when we configure PE2. So this is for PE2. We are not going to do it on PE2 anything now. So what next is, this need to be configured also on all the core routers. So the core routers are Olive 5. Olive 5 has got different interface name, EM0, EM1. So what I'll do, I'll put EM0 here. And now I'm going to paste this on Olive 5 and Olive 6. Olive 5 EM0 commit, and also on Olive 6. Okay, perfectly done. So MPLS is now running on all the device. Okay, if I did not do it on the loopback, it needs to be also on the loopback. So let me put it on all routers. It was right hiding down, so I didn't notice. Okay, commit. I'll also paste a copy on this for router 2. Alright. What next is so what is done so far is MPLS LDP enabled. So we have finished 4 steps so far. The 5th step is loopback interface configuration as router ID and LDP transport. Step 5. So we are configuring loopback interface. So far I have not configured IP address on the loopback interface, so we are doing it now. This is the known command: set loopback interface inet address. So PE1, let me copy for PE2. Alright, so for PE1, set interface loopback 0, unit 0, and then family inet, and then address is 101.101.1/32. Right, so similar job we have to do it on Olive and Olive 5 and Olive 6. So I just go to Olive 5 and say fider/5/32, commit, and Olive 6 6.6.6/32, done. And then the next step in the list is the VRF configuration on the PE router. Alright, so let's see the VRF configuration. Set route instance, give any name. This is the VRF name. Here instead of the word VRF we say routing instance, and then the instance type is VRF, and then this will be having this interface as a member, meaning this is the customer facing interface. Customer facing interface, very important for customer facing interface. And we don't configure this on the provider only router, only you need to do it only on the customer connected routers, which is called PEs, provider edge routers. And we all know that for VRF, route distinguishers, to differentiate one customer update from another, we need this, and this is locally significant, and this is 64-bit. And we also know that we need route target, that's also another 64-bit. 64-bit to 128-bit. If you use community, here they are using community, so it becomes 128-bit. So this is same like Cisco, but only the approaches, configuration approach is different. And the route distinguisher can be same, can also be different. Just to prove that, here it is given different number. But even if I put 1 and 1 here, it is okay. But we should not think that it must match. Yeah, route target must match. For import and export, it must match. But for a route distinguisher, it can be different number, just to prove that 2 different number is given. That we have done this in Cisco. We have learned this. Whether it is Cisco or any vendor, Juniper or any vendor, rule is same. Route distinguisher is locally significant, so can be different or same, doesn't matter. Right, I'm going to put this on P1. Instance route target, route distinguisher, and the number is 100:1, and then route instance, and next is the route target. So we say here VRF target, not route target, VRF target, that's the community name, colon 100:1. Am I right? Yes. Okay. So this is done. Route target, route distinguisher. Now I'm going to save this for P2 on the other document. This is for recap. I'm not pasting it on the device. Okay. So the next is the customer facing interface needs an IP address. So we put the IP address. According to the plan, 11.0.0.1 should go on EM0 here, and 22.0.0.22 should go on EM0 on this PE2. So P1 customer facing interface configuration. Done. For P2, we will save it for later. Copy. Okay, so that's step number 7. Step number 8 is within the core between the PEs to form MPBGP. We say set protocol BGP, the group name is IBGP, and we are going to say internal because it's IBGP between PEs. We are forming VPN using this local address, the loopback. Here we don't need to say update source command, we use the local address command, and then the neighbor is 22222, and the family type is iNet VPN, IPv4 VPN, layer 3 VPN. This is important. This is like address family VPN v4 command in Cisco. Right, so looks clean, so I'm going to copy paste this on PE1. Family iNet VPN unicast. Alright, so internal, okay, what is missing is the neighbor. Neighbor is 2.2.2.2. What else? That's it. So we have error in neighbor 2222 group IBGP must define the local autonomous. Aha. Local AS is 20 in our topology. It is 20. Local AS 20. Now I'll say commit. It should accept yes. So this is missing piece in a document.
Wow.
On P1, I'm pasting this. Okay, it's only copying one line at a time. It's because of the buffer limit. Oh, neighbor. I think it is 11.0.0.1. That's the customer IP address. 11.0.0.1. Okay. So the next line is this. Meaning we are going to use IPv4 with the customer. And then this is to take the customer root into the VRF table and put it in VPN. Done. And this is the command that puts into the VPN exports. Alright, so commit. Error in neighbor 11. Again the same problem. Local autonomous system is missing. We put the local AS and we commit. It helps. So the next thing is EBGP address is carried into IBGP. The routes coming from customer will be placed inside the VPN without changing the next hop. So to make it to make the P router to put its own address, we need to put this command next hop self. Command next hop self. Not there. Let's display and see. Show config. Show config. Protocol. Show config. Okay, so what we have IBGP for layer 3 VPN done. Next, show configuration, routing options. Okay, routing instance, show configuration, routing instance. Okay, this is for the VRF. So what I have is custody is the VRF name, and this is the interface of the customer or destination or target. This is for binding, and then BGP is running under that VRF. This is VRF aware routing, and it is EBGP IPv4 correct. Export policy done. Looks good. Looks very good. What is next? Next step. One minute, let me put this in the other document. Missing piece. the final step on the customer side, this need to be done. We have already done on the customer side, and instead of saying direct, we put a filter. Let me show you that. Oh no, root JUNIPER123 root ER123. Okay, and now CLI config, or when I say show route option, policy option, policy show config policy options. This is what we are putting a route filter, and we are advertising only this loopback. But in the document example, what we have is all directly connected network, both 11.0.0.1 and 172.16.0.1. But in the real world, I don't think we'll be advertising this network that we use for neighborship. We do only this internal networks. So what we have is already good. Alright, so this is also done. That's it. Now we are going to do the verifications. Here show BGP adjacency or neighbor. We can see established. Very good. Our configuration really worked well. We can also use that similar BGP Cisco command, similar to this, like a show BGP summary. Cisco like output you can see, and it is up for almost 8 minutes and 17 seconds. We will do some verification, checking on the PE side. I'm going to say here show BGP summary. Yeah, we can see established for the CPE, but not for IBGP. That's okay.
Right.
Because we have not finished PE2 yet. Now to check the route that we are learning, I'd like to copy this and say show route for this VRF. Show route is it route instance no correct,
yeah, instance. There it is, yeah, right.
Instance, and then the instance name is this.
So instead of VRF, it's instance.
Correct.
Of course.
Node 0. Okay, here it is. It says that, but I'm not seeing what I'm expecting. Okay, simply we'll type show route, then we will come back here. When we type show route, it will show you everything, even the global routing table, the customer. This is the customer A routing table, which I was trying to filter. See, we are learning the route.
Yes, I see it.
Yep. And now let me figure out how to get this table filtered.
Oh, there you go. That's it.
Show route instance.
paste. Yeah.
No.
No.
Maybe I need to try the missing piece. Protocol is one. Okay, let me try protocol BGP. Yeah. So this is
Right.
but you know I'm getting what I want. That's what. But I'm still not getting that particular instance alone. I'm getting the BGP stuff. Protocol. Do I have instance here? No, not possible. But there is definitely command to.
Command. Let me see if I can find it as well. What do you want the command to show you? The
Only the VRF table, routing table.
Table in Juniper.
Route table for.
Okay, I think I know which one. It's according to this one is show route.
Oh, the table was missing. Show route table.
And then the VRF table you paste.
Yes.
Yeah, that one.
Okay, the word table matters here.
Yeah.
Table.
Okay. I was using Claude, but Claude is more it makes less mistakes. I've noticed.
Okay.
Yeah, maybe.
Right, we verified this. Now what about the ISIS? Show ISIS adjacency. We can see two adjacencies are there. But in our case, we have not suppressed L1. We still have L1. It is okay. Now, what else need to be taken? The LDP. Show MPLS neighbor or adjacency. Or show MPLS LDP. Show MPLS interfaces. TERS. What is this? Show MPLS. Show LDP neighbor. No. Let me go check the MPLS configuration. Show configuration MPLS.
Yes.
Show MPLS. Show configuration LDP. Show configuration route option MPLS. Or protocol, show configuration protocol MPLS. Yeah. It is running on these two interfaces. Okay.
Very good.
But when I type show protocol or show LDP,
nice.
ping to the 2 with the source loopback 0. This is the reason.
Oh, I see. No route to the host.
ISIS is not running on loopback.
Right.
Show route protocol ISIS. We don't have route to reach 22222. First of all, I should not check 2222. 5 and 6 are directly connected. Router 2 PE2 we didn't even configure. It's okay. Now, but why LDP neighbors are not there? I am supposed to see LDP neighbors. Show LDP neighbor. Why? Show configuration. Okay, here it is, MPLS. Let me try adding loopback to this. Set protocol. Set protocol MPLS interface loopback 0.0. Okay, I'll put the same on only 5. Show LDP neighbor. Why? What is missing in MPLS? This one. Set interface em0.0 means em0 unit 0 unit, I think it is space 0 family MPLS. That interface need to be enabled with MPLS. This is a missing piece. Like family, we say IPv4 inet, right? Likewise, this is MPLS.
I see. Wow.
Now I'm going to put this thing on P1. What is the interface name? Now if I ask LDP neighbor, it should be there. Show MPLS LDP. Not from here. Show MPLS LDP, not an MPLS LDP, simply LDP neighbor. It is that problem. So we figured out the problem here. Now we will go. Okay, one more thing. Show MPLS interfaces. It should show now. Yeah, it shows now. Okay, now I'm going to P1. Sorry, Olive 6. We are going to paste the same command. Olive 6. Okay. So we now go to P1 to check. Show MPLS. Sorry, show not here. Show LDP neighbor. I should see two neighbors. It is. So we are now good to go with router 2 configuration. I can see all of the things are in place. We learned the route, and this router is ready to form VPN. MPLS is running, LDP is running. So if I bring this P2 up, with all necessary configuration, then I should be able to ping from site 1 to site 2 of customer 1. So shall we do now PE2?